So we're here to define general angles and use radian measure. Okay, so what we're going to be focusing in this section is dealing with angles that are in the coordinate plane. Okay, so now usually when we talk about angles and we work with angles, we talk about geometry and angles and those, some finite shapes. But what we're going to be working with here is angles in the coordinate plane and how that has an effect on us moving forward with some of the trigonometry that we're going to be learning. Okay, so the first thing is understanding where angles are in standard position within a coordinate plane. Okay, so if you look at this image here that we have in this key concept, you have the coordinate plane with the x and y. Okay, and there's two parts of the angle, or the sides of the angle, that we want to talk about. Okay, so the first part is the initial side, which is here. Okay, the initial side is always going to be on this positive x-axis. Okay, that's always where the first ray of the angle is going to be drawn. The second one we have here is what's called the terminal side. So the word terminal kind of, when you think of terminal, you think of airports, right? Airports have different terminals. Terminal is just a way, kind of another way to represent stops. So the initial side of the angle starts on the x-axis, and the terminal side is going to be the ending location of this angle. Now notice that to get from the initial side to the terminal side, we actually traveled in this direction here, okay, as shown by the two arrows in the picture. So all positive measurements of angles are going to go counterclockwise. That's how we measure those, all right? Now you'll figure out later on that we can go counterclockwise, but for now, the ones we're going to be working with are the positive angles, and they're all measured counterclockwise. Now, I just want to point out some major angles here that you should kind of understand why that's the case. So when we talk about the x and the y-axis, we know that they are perpendicular to each other because one is horizontal and the other is vertical, right? So if we start on the initial side, so let's say I start here with my first ray. Okay, so I start here from the origin and I'm drawing it on the positive x-axis. Okay, this is technically 0 degrees because you're not forming an angle, right? As I travel, if I get to this y-axis, if that's where my angle finishes, that would be 90 degrees. If I keep going and I create a straight angle, that's 180 degrees. If I go to the negative y-axis, that's going to be 270 degrees. And technically, I could come all the way back around and end here at 360. Okay, so if I wanted to draw, let's say, an angle of 225 degrees, where do you think 225 degrees would be? Will it be in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? So you just look at the measurements starting with the initial side, right? So where would 225 fall between? Well, that's going to fall between the 180 and the 270 degrees. So therefore, when I draw my angle, I know it's going to be somewhere in here. Okay, and remember, we're going to draw how we got to this position. So you're going to draw the motion in which it traveled there. So it started from the initial side and it ended on the terminal side there. So that would be the measurement of 225 degrees, okay? And it's in standard position again because the initial side here starts on the positive x-axis and the terminal side ends in quadrant 3 at 225 degrees, okay? So now the one thing I kind of want to tell you guys about is that angles technically can have an infinite number of degrees, and it all depends on kind of like the amount of times you can rotate around the x-axis. So think of this like one of those spinners that you get in, like, little board games where you have the spinner and you can, choose a color based on the spinner. If you flick this arrow here, it can infinitely go around the spinner as many times as possible, and you're kind of creating an angle. And those angles are kind of calculated throughout time and certain functions that we're going to work with moving forward. Okay, so coterminal angles. All right, so the idea of the word coterminal is that co meaning two and terminal meaning the ending the terminal side of the angle, right? So what a coterminal angle is an angle that shares the same exact terminal side of the angle, right? So let's take a look at, let's do a simple one here. So let's say I had an initial angle and I drew initial side and a terminal side here. Okay, what would be the measurement of this angle? Now, if I drew it like this, with the arrow going there, this would be a 90-degree angle, right? Because it's going from the positive x-axis and it ends at the positive y-axis. Now, let's say I drew the same or a similar one, okay? Initial side is here. My terminal side is here, okay? But what if I did this? Let's say I started here, I went all the way around, and then I ended there. What would be the measurement then? Okay, so what we have to think about is how the angle traveled there, right? So if it started on the initial side and it traveled all the way around, okay, how many degrees would be all the way around? 360, right? It did one entire revolution. And then it continued up to the 90% point, so we have to add 90. When we take 360 and we add 90, that gives me 450. So this angle here is actually a 450-degree angle, while this angle here is a 90-degree angle. Now notice that they're both drawn the same way, except that the little arrow kind of tells us how many revolutions there were. So by definition, what the coterminal angle is just different variations of the same angle, but based on number of revolutions, right? So to find coterminals, let's say we had a 45-degree angle. A coterminal to that, we can just add 360 to get a coterminal for 45. If we add 360, that gives me 405. Okay, so that's one coterminal angle. You can also subtract. Okay, subtracting will just make the angle negative, and what that means is instead of going in the positive direction, your angle will actually go in the negative direction. Okay, so if we subtract 360 here, we'll get negative 315 degrees, and negative 315 degrees is also going to look the same, except the arrow with the number of rotations is going to be different. There's a number of revolutions. All right, so that's how we can draw angles that lie beyond 360, and that's the definition of a coterminal. All you need to know is either you're going to add or subtract 360, because 360 represents one entire revolution of an angle. Okay, here, so we're going to draw an angle with the given measure in standard position, then find one positive coterminal angle and one negative coterminal angle. Okay, so let's look at number one. Okay, so number one is a 65-degree angle. Now, we're not going to be as accurate as we're supposed to be. We're in the ballpark area, right? So a 65-degree angle, if I drew that in standard position, I know my initial side is going to be here. Okay, now my terminal side needs to lie somewhere between 0 and 90, but probably closer to 90 because it is in quadrant 1. All right, and then what you need to do is you also need to draw the arrow from the initial side to the terminal side. Then it says find one positive coterminal angle and one negative coterminal angle. Okay, so 65 plus 360 gives me 425. So that's going to be one positive coterminal angle. And then 65 minus 360 is negative 295. So there is one negative coterminal angle. Okay, let's look at number 2. Okay, so 230 degrees. So where is the terminal side of this 230-degree angle going to be? Well, again, we have our initial side here. I know that this is a 0, this is a 90, this is 180, and this is 270. So where do we need to draw the 230-degree mark? That's going to be between 180 and 270. And then we need to make sure it's a little bit closer to 270 than it is to 180. Okay, and then we need to draw the arrow that shows us how we got there. So we got there starting at the initial side and ending on the terminal side. And then we need to find a positive coterminal angle and a negative coterminal angle. So we have 230 plus 360. That's going to give me 590. That's a positive coterminal angle. And 230 minus 360 is negative 130, which is a negative. So we have one positive, one negative, and there you go. Those are the two angles. All right. Now, if you get in the hang of this, I want you to go ahead and try number 4. And, just fast forward the video to get there. But if not, then just stick around, and I'll show you how to do number 4. I am going to erase what we have here, just to give us a little bit of space to work with. And then we'll start those short. All right, so here's 3, and then 4. Okay, so number 3, we are going to draw a 300-degree angle. So initial sides here, and 300-degree angle. So 90, this is 90, 180, 270, 0, or 360. So we're going to definitely draw this between 270 and 360, but it's going to be closer to 270. Okay, so there's your angle. We are traveling in this direction from initial to terminal side. Then they want us to find coterminals, so we're going to take 300 and add 360. That gives us 660 degrees as one coterminal, and we're going to do the same by finding a negative one, so subtract 360, and we get negative 60. Okay, there is a positive and a negative coterminal. All right, this last one, number 4, 740, we're going to start here. Okay, so now 740 is interesting, right? Because it doesn't lie between the normal ones we would normally use, which is 0, 90, 180, 270, 360. Actually lies beyond that, right? So the first question is, how many times do I have to draw a revolution, right? So we can figure that out by subtracting. So if I subtract 360 here, I get 0, 8, 380. So this is one revolution. It looks like I can subtract another 360. So that's going to be my second revolution. So what I'm left with here is a 20-degree angle. So that's going to tell me that my angle is going to look like a 20-degree angle. But when I draw my arrow here, I'm going to go 1, 2, and then stop at my angle. The reason why I'm doing 2 revolutions is because I was able to subtract 360 twice from this very, very large angle, okay? Because I was able to do that, that actually gives me the information I need, so when I draw how many times it revolves around the coordinate plane, I can show that it revolved twice, and then it stopped at the 20-degree angle, okay? Then it says find a positive and a negative coterminal angle. Well, technically, this is a positive coterminal angle, 380 degrees, okay? So we don't need to do more work there. The only thing is we need to find a negative coterminal angle. So we have to continue to subtract 360 until these numbers get negative. So 20 minus 360 is actually negative 340. So there you go. There is your negative coterminal angle, okay? So when you have an angle that lies beyond 360, to find a negative coterminal angle, you're going to keep subtracting 360 until you finally get a negative angle. Okay, so if you want to use a calculator, you can, but that's pretty much the approach you want to take when you're trying to find the coterminal for negative value for a very large angle. Just keep subtracting multiples of 360 until you get a negative 1. Okay, all right, so let's talk about radian measure. All right, so when we work in geometry, we're usually used to degree measurement. Okay, radian measurement is actually just another variant form of finding measurements in of angles. Okay, now the radian measure is actually mostly used in higher levels of Algebra 2, and in pre-calculus, calculus, we use radian measure a lot. That's like the standard measurement where we start talking about circles and their relationships as a function. So the radian measure kind of comes from the circumference of a circle. Okay, so let's say you had a circle here. The circumference of the circle is 2 pi r. Okay, based on the the radius of the circle, right? So this could be the radius r. The idea of the radian is that the radian is actually kind of similar. It goes hand in hand with the arc length here. So like, let's say I needed to find the arc measurement for a particular piece of the circumference, right? So what we need to know is that 360 degrees of a circle is equivalent to 2 pi radians. All right, and that kind of comes from the circumference itself, right? We use 2 pi specifically because it's in degrees. So we need to understand that 2 pi radians is the same thing as 360 degrees, okay? If we divide both sides by 2, I know that 180 degrees is actually equal to 1 pi radians. Okay, so now we're going to be working with a lot of these pi measurements in radians because they're kind of standard when we work with these radian measurements. So these are the two relationships that you kind of need to know because we can kind of get everything else just based on this information, okay? And especially this one here, this one's very important. It's actually going to be on the next slide when we start talking about converting from degree to radian measurement. Again, it all comes from the circumference of a circle. Okay, so there's two different variants here. And it all depends on what we're trying to do. The first one is degrees to radians. So we're going to take any measurement in degree and multiply it by pi over 180 radians to get the radian measurement. So again, multiply by pi over 180. If we're going in the other direction where we're taking a radian and changing it into degree, we're actually going to be multiplying by 180 over pi. All right, so it all depends on which one we're going to convert into. So again, notice that the measurements here are radians over degrees, and this one is degrees over radians. So just kind of focus on which one you need to use when you're converting. So let's do a few here. All right, so notice it's kind of split in the middle here. Right, left-hand side is degrees. We're going to convert that to radians. Right-hand side is, it's already in radians, let's convert it to degrees. Okay, so let's look at 5. So we have 135. We're going to multiply that by pi over 180. Okay, so what you want to do here is you want to simplify it as best as you can. I know from experience that they're both divisible by 45. So that's going to give me 3 pi over 4. And that's your simplified radian measurement, and there you go. Okay, you converted your degrees into radians. Let's look at number 6. Number 6, we're going to have negative 50 times pi over 180. Okay, so let's simplify here. We know the zeros can cancel out. Negative 5 and negative 18 do not have anything else in common, so I'm actually going to get negative 5 pi over 18. Now, since your original angle was negative, your radian needs to also be negative. So just make sure of that when you're working on these problems. All right, let's look at 7. So 7, I have 5 pi over 4. But in this case, I'm going to convert it from radians to degrees. So what I'm going to multiply by is 180 over pi. Now, in this format, notice that the pi's are going to cancel out. So that's how you can tell that your answer is no longer going to be in radians because your pi's are going to eliminate here. And then simplify this as best as you can. So 180 goes into, 4 goes into 180 45 times. Okay, and then we have 5 times 45. So that's going to be 225. Okay, and then the last one, number 8, we have pi over 10. We're going to multiply that by 180 over pi. Pi is canceled. The 10 is going to divide into 180 18 times, so this is an 80-degree angle. Okay, so very simple. Just understand which one you have to do and simplify your fraction as best as you can so that you can get the correct measurement. Okay, so now this is definitely going to be for your notebook once we get into some more difficult, concepts in this section. What I want you to kind of copy down here is this entire circle, and I want you to list both the degree measurement and the radian measurement for each of these special angles. Now, the reason why we like to use a lot of them, if you kind of pay close attention, the first three angles are 30, 45, and 60, and that comes from the 30, 60, 90 triangles that we kind of went over a little bit in the previous section, and the 45, 45, 90 triangles. So those are kind of special angles. And then these angles kind of repeat in all the other quadrants, okay, but just as much larger angles. So they're kind of just using these special right triangles very often. And then we also care about the 0, 90, 180, and 270 because those are all on the x and the y axis. So these are just special types, and they luckily gave us the radian with the degree measurement, so we don't have to do them by brute force. The book actually gives us a guide on what those are. So moving forward, you can copy this down and use it forward in your notes, and always reference it if you need to convert from 1 degree to a radian or from a radian to a degree. Okay, and then the last thing we're going to cover here is arc length and area sector. Now, this may have not been taught in geometry. It kind of depends on how far your geometry class went, if they got into area near the end of the year. But the idea is the arc length is the length from this, from the circumference. So it's just a measurement of the arc here. And then the sector is kind of like your pizza slice. It's always going to be the area of the slice of pizza that you want to take out here. Okay, so we have a formula for each, and this is again in radians. So once you have your radians, all you have to do is plug it into those formulas, and you'll be able to work it out quite simply. So I do have a problem for you here, just to kind of show you an example of that. So here we have a softball field forms a sector with the dimensions shown. Find the length of the outfield fence. So we want to find the length of the outfield fence here. And then we want to find the area of the field, and the area of the field is going to be this entire sector. Okay, so we need to do both. We need to find both the length of the outfield fence. So the outfield fence is just going to be the arc length there. So I know arc length is S equals R theta. So what is the radian? So we have a 90-degree angle here. Okay. The 90-degree angles in degrees. I need to convert that into radians first. So that's going to be times pi over 180. So that's going to give me pi over 2. So it's going to be pi over 2 as my angle times the radius, which is 180. So this is actually going to be equal to 90 pi. Okay, and then whatever that comes out to in the calculator is going to be the result of your problem. Okay, so you could just plug that into a calculator to get the more accurate result. And that's going to be the length of the outfield fence that you're going to have for this softball field. Okay, the second part of it is we want to find the area of the field. So the area of the field is going to be A equals 1/2 radius squared theta. So A is going to be equal to 1/2. The radius squared is going to be 180 squared. And then that's going to be times the radian of pi over 2, which we found for the previous example. So if I just simplify this just a little bit here, I'm going to get pi over 4 times 180 squared, okay? And then again, plug that into a calculator, and then you're going to get whatever the area is going to be for the problem, okay? So that's how you use those two formulas. But again, that's pretty much it for the section. We covered how to draw angles in a coordinate plane, how to calculate what their degree measurement is, what is a coterminal, and how to find them. Okay, and then we discussed how to convert from between the degree angle and a radian angle. So those are the major topics that we learned in this section. Hopefully this video helps you. Again, if you have any questions, you can always leave a question on Google Classroom. All right, thanks for watching, and I hope this video helps you guys out. Thank you.